All right, we're recording. And just thought we'd do something fun this morning. We'll see how it may not take very long, but we'll see what we can do. I was just going to uh, try and make something fun for like events and parties, which is doing some special effects based on the user's movement in the scene. So just in this case, I just all I think I've done so far is I dropped in just a generic uh, humanoid model. This is just our old avatar model. Not very exciting, but useful to get started with. And then there is just a animator on this model somewhere. There we go. Dance controller. And so I just dropped in a dance. We can just scrub through this and just kind of see what a preview of what the dance looks like. Just kind of throw that out there, and we can play this. And we can just see if we drop in here. She's just doing a looping dancing. I don't know why the the current avatar on the preview servers for this account is an elf, but you know it's almost the right season for that. But then we got our little dancer here. And so what we're going to do is we're going to try and make it so that every time that her foot lifts and then drops onto the ground, like every time there's an impact, then we get a particle effect where her foot landed. And so that way, when you're dancing around the scene, every time you put your foot down, some kind of cool particle effect happens. And that particle effect can be like randomized. It should work with any dance, no matter what you're doing. So you can switch between dances, and it doesn't have to be like pre-choreographed or anything. As you move around, even if you're just like running through the scene, even you can make it have impact points in the scene. And we're trying to do that in a way that's not overly resource intensive when it comes to playing the particles. So just make something a little bit here. So what we're going to do with that is we're going to, I picked out a particle just so we'd have that ahead of time, just something we happen to have in our library already. And that is just playing a little explosion, something just a little impact poof there. It happens to be red, which is not a terribly visible color, but uh, apparently Louis thought we canceled it today because Simon wasn't here.
Simon is not here. It's cancelled.
Yeah, let's see. Anyway, so he'll be here in a moment. But what we're going to do here is we're just going to go ahead and build ourselves a script. So we just got, we'll just add a scripting runtime. And we don't actually have a script made yet, so we're just going to do that. We'll just say new text document, and we'll call it dance effect script .lua. And now we're over here, and we can attach our dance effect script, and we'll go ahead and attach, well, wrong one. Got to do library 2. Go ahead and attach our logger, just in case we need it. And then we'll need to tell it what our particle is. So we're going to do a couple things here. We'll say add an object reference, and we'll call this effect, and we'll attach our red impact ring there. And then to kind of keep things simple, we'll just tell it what our where our feet are. There's, to convert this to use for avatars, we'll want to make that dynamic, but for uh, for our little test dummy here, we're just going to start off by just telling it where the feet are to begin with. So we're just going to open up the skeleton here, and we've got left leg, we've got right leg. But if we look at these, we can see that like the foot, these actually refer to the joints in the body, and the what is actually the foot is not really where we want it to be. So we can see the pivot of that is actually at the ankle, right? So if we pivot that, then we're actually pivoting the whole foot at the ankle, which is not going to be a great place to kind of detect an impact from where your ankle is. So actually what we're going to do is we're going to look at the toes instead. And that way, anytime so the main part of your foot hits the ground, then hopefully that we can use that as a more valid detection point. So what we'll do here is we're going to come over here and we're going to say left foot, although we're really detecting the toes. And then we're going to come over here and say right foot. And again, we're detecting the toes just on the other foot there, which is there. There we go. And so that will hopefully be a more useful place to detect from. And what we've got from there is, let's see, we got a couple of people joining us. If you guys want to speak, feel free. I'll add you to the speaker list. But otherwise, we're just going to, you can also chat in the text chat, but otherwise, we're just going to do a little scripting here and hopefully have something interesting to look at afterwards. You have no audio. Everyone else does, so you're going to have to play with your Discord settings here. You have to play with your Discord settings. Everyone else can hear. Probably on the audio device. Mismatch or volume.
Loud and clear.
Yeah, everyone else can hear, so they're just going to have to play with their individual volume settings and see if they can figure that out. All right, so let's talk about how we do that then. We're going to just pop over to our script here, grab our dance effect script here. All right, so we're going to need a couple things. One is we need to know what our effect is. So effect, we're going to call this our effect template, and we're going to say get our reference to the effect object. And we're calling that a template because we're supplying it one object, but there's 2 feet. And in the future, you could expand it to do something like hands also. So like if you're breakdancing, anytime you put your hand on the ground, you'd also get an effect also. So there may be multiple effects going on. And so what we're actually going to do is we're actually on startup, take this object and make as many copies of it as we need at runtime. So even though we call it effect, it's really a template that we're going to duplicate. And then we're for now we're just going to say left foot get reference left foot, and we'll do one for the right foot. All right, so we got our references together, and so what do we need to do now? Well, we need we're going to need either an update function or a coroutine, something that runs a lot, and we're going to do this as a coroutine, specifically because if it's an update function, then it means it runs every frame no matter what, even if you don't want it to do anything, you just still have to have something that's going, should I be doing something? No. Should I be doing something? No. And that's kind of pointless. So I kind of envision this being something that's attached to like a dance machine. So you would only want it to be active when the user clicks on like the dance ball or whatever and initiates a dance. And then when they stop dancing, this goes away. And so anytime you've got something that needs to run, like even if it's every frame, but only some of the time, that's better as a coroutine. So we're just going to make ourselves a new function, and we're going to call it dance coroutine. And then we're going to write ourselves a new an initialization function here. And what do we need to do with that? Well, we need to do what I said earlier to start off with, which is make some copies of this. So we're going to make we'll make some new effects here. So we're going to say right foot effect. All right, so we need to do something with those. We're going to say left foot effect is our effect template duplicated. We're making a new copy of that. And we actually don't need to put it anywhere at the moment because that comes later, but it needs to exist. And we're going to want to make sure that it is active. And then we're going to want to do the same thing for the right foot, get an effect ready to go. All right, so we got these pre-made. And one thing we're going to want to do with our particle script is make sure that it does not play on awake. We don't want it to play until we specifically tell it that it's time to play. So we're just going to turn that off. And what we're going to also do here is we're going to add a scripting event to this. And we'll add one event here, and we'll just call this play. And for now, all that's going to do is call particle system play. And the reason I'm doing that is because this makes it more versatile. I could just directly call particle system play. If we go look at like our component library, we can see that there is a particle system component that we can access to, and it has a play function that's built into it also. Play with children, etc. But by hooking it up to a scripting event component instead and letting the event component do that, that means if I wanted to, I could have this do any number of things on impact, like the script that detects the impact and makes something happen on impact doesn't have to always be particles. We're choosing to do particles here, but by just saying, yeah, whenever your foot touches the ground, this event happens, then you could have any number of, you could swap out the effects for all kinds of different things and just have it determined by what you have here in a Unity standard event, which can do any number of things, start particle systems, play audio, call a script function, any sort of standard Unity activity could trigger off a different animation on something else, right? So, if you could have it so that like whenever your foot went down, that triggered an animation on like some nearby objects or something. You can do all sorts of interesting things with it, but that way the script itself doesn't actually have to know what the effect is. It just has to say, do your effect, whatever it is that you think you should be doing right now. So there's that, and we're just going to apply that to our particle prefab, and then we'll come back to our script. All right, so right now we're just going to assume that this just happens on startup, just for our initial little prototype here. So we're going to say space.host start coroutine dance routine, get that started. And then we just need to decide, okay, what happens in our dance routine? Like I said, if this were hooked up to a machine, you'd want to first of all have some way to know whether this was still going or not. So we're going to have a dancing variable here. We're going to say dancing's false, and to start off with, we'll say dancing's equal true. Now start our dance routine, and then we can say while dancing, and that way it's if at any point dancing gets set back to false, then this whole function will just automatically stop. So if it's like attached to a dance machine or something, then you're like, they're dancing, they press the stop button, all right, we're not dancing anymore, this coroutine would automatically end. But while it's not ending, we do need to yield uh, so that other things can happen. And we're going to yield 0, which means yield for only a single frame. If you yield for 0 time, then it's going to play again as soon as possible, but not on this frame. Yield automatically means you're done for this render frame, and so when the next render frame comes around, it's going to go, yeah, it's been 0 seconds since you last did this, so it's going to run again on the next frame. So every single frame will be doing something here. And what are we doing? Well, we want to find out anytime that this character's feet touch the ground. So we can see here it's like lift and touch, and we want that to be detected that that foot is now back on the ground. Foot up, foot down. We want to know when that happens and where it happens. So what we're going to do is we're just going to do a little raycast here. We are going to say, um, we'll make ourselves some variables here. It's more efficient that way. If we define these variables outside of the while loop, then that means they only get defined once for this whole function. Whereas if we were to define these inside the while loop, then that means every single frame it's deleting and remaking these variables over and over again, and that's very inefficient. So we're just going to put it right there. And we're going to be changing the value of these every frame, but we're not going to be sort of reallocating the memory for them. And so what we're going to do there now is we want to do a little raycast. And so we can go look at our scripting guide here. And what we're looking for is our physics library. So we're going to do raycast single specifically, and that needs an origin, a normal, which is a direction really that it's going, how far out it casts, and optionally a layer mask. So we will come back here and we'll say that left ray is equal to space.physics.raycast single. And what is the origin? Well, the origin is going to be from our left foot, specifically whatever the world position of our left foot currently is. And what is the direction? Well, we're looking for them hitting the floor. So the direction we always want to be down. I'm going to say, like, take their foot, go down from their foot, and see if the foot see if there's any objects directly below the foot. So we're just going to say, I believe there's a shortcut we can use that's just vector.down. This is a static variable that's predefined just because it's so often useful. If we go over to svector, then you can see here that there's a bunch of these static vectors assigned here. Up is 0, 1, 0, down is 0, -1, 0, and so forth. So you can just do vector.up, vector.left, vector.right, so forth. And then these are always, in this context, these are always going to be like from the world space position. If you wanted to get like a specific object's downward vector, like the -y off of a specific object, you wouldn't use vector.down. You would use that object as a way to get its own local down. But in this case, we just want the world space down. What is down to reality, to gravity, because we want to know when the foot is hitting the floor, not necessarily anything else. And since we only care about when the foot is actually, like actually touching the floor, we don't need to send a very big ray. We just need to send a little itty bitty ray. So we're just going to start off by sending like 1/10 of a meter ray down. And then we're going to do the same thing on the right foot. And now we can say, really just go over here. Now we say if left ray dot contains hit, right? Because that's part of whenever we raycast, we get back an S physics hit object, and part of that object is just a Boolean that says, did I detect anything at all? Or did I cast a ray and it got to the end of its distance and didn't find anything? Then that would come back as false. So we want to know if it found something just in our little tiny little tenth of a meter jump. And so what we're going to do there is we also need to think about, we only care about this if this is new. This is a new impact, right? So we want them to lift their foot and then put their foot back down. And that's when we want something to happen. If we just carry on like this without caring about the lift and only detecting if they're standing on something, then it's just going to be like throwing particles constantly when they're just standing there doing nothing because their foot is always touching the ground, and that's not what we're after. We don't want anything to happen until they lift and then down, lift and then down. So what we need to do here is kind of keep track whether their foot is up or whether their foot is down. So we're going to say like left is up, and we're going to say right is up. All right, so we're going to say if we contain a hit and left is currently up, that's when we want to actually do something. But we need to make left is up actually work for us. So we're going to say here that left is no longer up because it was up, and we've detected that we've hit something. So that means left is down now. So we're turning that off. But we need to know when they were off the ground in the first place. So this is going to be left is up is true. So whenever time we cast a ray, we're going to say, all right, send a little probe down from the bottom of their foot and see if they've hit anything on the ground. If they have, and they were currently, their foot was previously off the ground in the last frame, then do an effect here. But remember that we just did an effect by turning this off so that we don't do one again until the next time that they lift their foot off the ground. So this should be anytime that, let's see, so if, not left is up and not left to ray that contains hit. All right, so anytime that their foot is not currently off the ground, but we no longer can find anything below their feet, then that means they've lifted their foot up. They were on the ground, but suddenly there's nothing under their feet that we can find. So we're going to say that their foot is up off the ground. And then that means we need to do an effect. So how do we do an effect? Well, what we're just going to do is we're just going to set our left foot effect, make that world position, and we're not going to make it the position of their foot. We're actually going to make it the position of what was under their foot. So whenever we look at a raycast hit, one of the things we get out of it is a position as to where that impact occurred. So we're just going to say that this is left ray dot position, not world position. Autocorrect is not helping me here. And then we're going to say left foot dot effect, and we know there's a scripting events component on there. So we're going to invoke the event that we made earlier, the play event, when we came over here and we added the scripting events component, and we said it has one event, and that event name is called play, and that's what actually sets the particle system off. So we're going to position the particles at the point of impact, and then we're going to tell it to play its particle effect. And then we need to do the same thing for the right foot, but we got to rename all of our variables. It's right ray. So There's that and that. And this is going to be right is up or not. So there's that. Let's make sure we get all of those changed. And then, of course, this is going to be right foot effect is going to be doing the same thing there. So that's the objects that we made earlier, just so we'd have them ready, and these wouldn't be null when we started up our coroutine here. All right. Now this is something that by moving this effect around, we could have it so that every single time you put your foot down, we did this. We generated a new object and then played that object and then deleted that object. Then the next time you put your foot down, it makes a new object. But that's very resource intensive to constantly be generating new objects, especially since we anticipate this is going to be happening a lot, right? If you're dancing around, your feet are moving, you're up, down, you're up, down, you're up, down constantly on both feet. And so that would be pretty resource intensive, just constantly making and destroying objects. So in this case, we are pre-making one object and just moving it around. So we're saying, oh, the impact's over here, so we'll move it over there, play particles. Move it over here, play particles. You have to be careful when you're doing that, because how well that works depends on the specific kind of particle that you're using. And so if you don't set the particle itself up right, that can look pretty strange. And we can play around with that once we get it working. And does line 27 need the last foot? It does. Yes, that would have been a fun bug. Thanks for the catch. Yep. Yeah, that would have been detecting the wrong foot there. Hazards of copying and pasting. You got to make sure that you go through every single reference. That otherwise, we would have noticed pretty quickly that whenever our left foot hit the ground, that a particle effect played on our right foot, and that would have been a little weird. All right, so we're going to save that, and let's just try it and see what happens. This is played before, so it shouldn't take very long. All right, we're getting something here. Yeah, so left foot, left foot, left foot. Every single time left foot touches, and notice it's actually positioned where the foot is going down. And if we go look at the scene, we can see, and you can see that we're not getting anything on the right foot, right? And that makes sense, because the right foot's not really ever coming off the ground, right? She's pivoting on her right foot, but she's not lifting her right foot. So we would not expect there to be any particle effect on the left foot. But the right foot is moving a lot, so that one is getting us a nice little effect. And if we go look at the scene view of this, and we go find, you can see down here, these are the objects that we cloned in order to do the effect. So we had our red ring impact sort of template object here. We made 2 copies of that. And this one is obviously the left foot copy. It's just sitting there because there has never been a case of the left foot lifting and then going back down. And so as a result, this object has never had to be needed to be moved yet. But if we look at our right foot effect, you can see that every single time that you touch the ground, that object gets moved to the point of impact and then plays its particle effect. So that actually works out pretty well. Now, a different dance where we got both feet off the ground, we could probably get the other foot going. Could be added to normal walks and runs. Yeah, actually, this is completely independent of the animation playing. I kind of envision it being used for dance machines. Like everybody, you could do fun things like whenever somebody clicks on the dance machine, this is a red explosion, but what if you had a blue, a green, a yellow, a white? You could have different versions of this effects that were all different colors, and then you could have it so that when somebody clicks on the dance machine, they pick one at random. Like, so I might be dancing with red particles, and you might be dancing with blue particles, and somebody else is dancing with green particles. And so then the whole dance scene is just like, this explosion of color as people dance when they put their foot down, then poof, poof, poof. But this doesn't actually have any connection to dancing directly. Like there's nothing in here that says, oh, this only somehow works with dance animations. This will actually work with any animation. Anytime your foot comes off the ground for any reason and goes back down, then you will get that effect. And it doesn't even have to be like, walking or running. Like it could be like, all right, I'm flying and I stop flying. That means my both of my feet were off the ground and now both of my feet are on the ground. And poof, you get a landing impact effect from the bottom of your feet because any all it cares about, all this script cares about, is that there was something under your feet and now there isn't, and now there is again. And anytime you get to that situation of there wasn't anything under your feet, but now there is again, poof, play a particle. So it doesn't matter what causes your feet to come off the ground. The particular animation is irrelevant. Now, that being said, you might need to be tuned slightly differently in that case. So just real quick here, I'm going to switch out the animation on this and see if we can get maybe get both feet. My mouse is not working well for me here. All right, so we got that dancing to. Let's put a different dancing animation in here. Just see how that goes. Now we got both feet. Every time the foot comes off the ground, we get a little effect. Poof. And now we're having an occasion now where both feet are coming off the ground. So if we go look at the scene again, we can see there's our left foot effect. Every time he lifts and drops on the left foot, you can see that moving back and forward. And same on the right foot, getting different impact point effects. But what I was saying about the tuning earlier was, yeah, this one prop in theory would handle any animation. It doesn't matter. Again, it doesn't matter what causes the foot to come off the ground, whether that's dancing, whether that's running, whatever. Anytime the foot comes away from the ground and then re-hits the ground, poof. And anything that causes the avatar's foot to lift off the ground and go back down, even if that's lifting the whole avatar and then putting the whole avatar back down, then you're going to get this little poof effect from where the actual impact point is. But yeah, what I was saying about the tuning earlier is the walking animation. So what I'm going to do is I'm going to break my scene component out here, and then I'm going to find our player, and we're just going to go look at our player here. Let me make this bigger because it's going to be really hard to see. So if we look at at us here, and in particular our feet, one of the things you'll notice is as if I walk, my feet don't necessarily come very far off the ground, like just a very tiny lift. Like when I'm walking back, I'm just almost moonwalking. Like my feet aren't actually coming off the ground a noticeable amount. Even when I'm walking forward, like there isn't a lot of lift. There might be enough because we're tracking from the toes, and so you can see that as I walk forward, my toes obviously kick up in the air a little bit. So you'd want to be careful about how the raycast was tuned, because if it's a kind of a if you're shuffling or if it's tuned to have the raycast be too short, then you might end up in a situation where I'm walking, but I'm not getting any effect just because my foot is not coming off the ground high enough in order to trigger it. Whereas something like a dance, I'm much more active. I'm lifting my feet deliberately, so it can be a little bit more aggressive in how much off the ground you want the foot to come. Running might be different. Like this, a walking animation might not trigger it, but running, you're typically going to lift your foot higher off the ground when you're running than when you're walking, so it might trigger it there. So it's just something to be aware of, that when you're playing with it, um, if you don't see the effect, it's not necessarily because, oh, it's this particular animation isn't set up right somehow. It's just that animation might not be causing you to lift your feet high enough. It's not rigged to a particular animation file or a particular animator component. It's just that, okay, the script wants the foot to come a certain amount off the ground and then go back down before it will do anything with it. So we can actually give that a try if we put it over here. Like, all right, so we've got our dancer going on over here, right? That seems to be working pretty well. But another thing we have to be wary of is like this just little dance character, right, is just, I placed them in the scene and they're pretty close to the ground, right? I placed them so that like their foot was like really on the ground when they're not moving. We could see that if I stop this and come down here, you can see like their foot is really close to the ground to start off with. If you didn't, it's not exactly on the ground, but if you didn't like get really low and look under their foot, it, for all intents and purposes, looks like they're standing on the ground. And our character might float a little higher off the ground naturally. So if we play this, you can see I'm a little bit higher off the ground than than this our sort of dancing mannequin over here is. So again, that's going to come down to how the raycast is tuned, and it's also going to come down to like individual outfits, right? Because you can go into the outfit window on your character and you can adjust what your hover height is off the ground. So if you've got a character and for some reason you've like turned that hover height way up so your character floats way off the ground, then you're not necessarily going to have this work very well. The reverse is also true. If if I pause this and I go over here and I grab my character, um, remember that the raycast is coming out of like my toes, right? So the front of my feet. And so that means like if I'm, if I'm hovering off the ground, but I'm only shooting a tiny little raycast, that's actually not going to go far enough down to hit the ground, and so I'll never see the effect. But likewise, if for some reason I had my hover height turned down too low and like the bottoms of my feet were through the ground, then that would also never work because it's too low, because that means that now my raycast is starting under the floor, which means it's never going to hit the floor because it's starting below the floor and going down, and there's just never going to be anything down there. So it's we really want our character to sort of our outfit to sort of be set up correctly, where we seem like we're at a reasonable height off the floor. Otherwise, this isn't going to really really work reliably. But let's see what we can do to make like a user version of this. So I'm going to leave our dancer alone over here, but I'm going to duplicate this and just call this player dancer. And we'll keep our effect, but we don't need a um, a mannequin anymore because we are going to be the mannequin. So what I'm going to do is I'm going to delete this out of here, and I'm going to make a new script, and we'll call it player dance effect script. Yes, I do want to change the extension. And then we'll come over here and we'll change this, because this has to work differently for us than it does this sort of mannequin in the object, and I don't want to mess that one up, so I'm just making a copy of that so that we can diverge these from here. And that also means that like I don't need the left foot, right foot anymore, because it's for the player, and the player doesn't exist until the scene starts. That means we're going to have to find my toes at runtime rather than already know where they are to start off with. So let's save that, but we'll keep the effect will be the same. So we go over here to dance effect. Let's let's copy what we had in dance effect first over to player dance effect and figure out how we modify it from there. Okay, so the first thing we're going to want to do is we're going to come over to our script and we're going to say wait for player, right? You can't even begin to look for my toes if my character doesn't even exist in the scene yet. So we're going to turn that on to start off with. Make sure we save this here. And that way we know when this script starts, our player at least exists. And what we're going to do here is um, remember that just because our player exists doesn't mean our outfit has loaded yet. So player exists means that there is an object in the scene that represents me. But if you watch our characters load when you load into a scene, you know that everyone starts off as like a spinny cube first, which doesn't have toes, right? So that's not, we can't actually do anything with the character at that stage. So it starts off as a little spinny cube, and depending on how many users are in the scene, if you drop into a scene that's got a couple hundred people in it or something, people might stay as a spinny cube for a while because at first everyone loads as a spinny cube, and then everyone loads as a silhouette, and then you start getting real outfits loaded after that. And so we kind of want to make sure that before we do anything, we actually have toes to work with. So what we're going to do is we're going to start a new routine here, and we're just going to call it function um, loading coroutine. And then what we're going to do on this is we're going to say that while, well, first of all, let's get a reference to our player. So who am I? Space dot scene dot player avatar. That's me. And we're going to say while my player, let's see, actually, while not my player is loaded, I think is what we're looking for. We can go over here to our scripting class and say avatar, that's just loaded. Is the avatar loaded? And we can also get a reference to the avatar's skeleton right here. So what we're going to say is while the player is not loaded, or their skeleton doesn't exist yet, then we're just going to wait. We'll wait 1 second and try again. Every second we're going to be like, all right, if they're not loaded or their skeleton doesn't exist, then just keep waiting. Once that's no longer true, then this while loop's going to end. That means they are loaded and they do have a skeleton. So at that point, find toes if they exist, right? And I say if they exist because we don't know what kind of and what kind of character this person is wearing. It's if they're wearing a costume avatar or some kind of like non-humanoid avatar, they might not even have toes. In which case we can't necessarily do anything with that. But most people are going to have toes probably of some kind, and we can be a little bit sort of flexible with that. But what we're going to do is we're going to use find bone. That's which is part of S avatars. So I should be able to do up here, instead of having predefined left and right feet, then what we're going to do down here is we're going to say right foot equals my player dot find bone. And what we really want is toes, right? So this is going to look for humanoid specific bones, and these are Unity standards. So you can come in here and be like, oh, it's there should be, as part of any humanoid defined character in Unity, especially anything that wants to use Mechanim for animation systems, there should be a left toes and a right toes. So we're going to do that. But what we're going to say is if right foot is nil, that means we didn't find anything. Like we asked for right toes, but we didn't get right toes. Then we can try a fallback of being like, okay, maybe there's some kind of non-standard avatar. Maybe they don't have toes, but maybe they've at least got feet. So let's see if we can find their right foot instead, which should be an option here. Again, for a lot of characters, that's the ankle bone, which is not necessarily going to be where we want to. That's why we're not looking for that on humanoids. If at all possible, we want to get the toes. But if they don't have toes, we'll try the foot bone and see what we can get from there. So we need to do the same thing for left foot and right foot. Right? We need to. We maybe found. We maybe found a right foot. Let's see if we can maybe find a left foot. This needs to be changed. Okay, and then we're just going to log out whether we actually found anything or not. So we're going to say right foot we found maybe is going to be right foot. Left foot we found maybe going to be left foot. That way we can see whether it actually returned anything that we care about. Now, in theory, if we say if left foot is not nil and right foot is not nil, right? We actually found feet of some kind. Then that's where we're going to start up our dance routine. And down here, instead of starting the dance routine on startup, we are going to do our loading coroutine. So that means when the script starts up, just like the other one, it makes copies of the effect so that it has those in its back pocket for later. And then it starts up this loading coroutine. And this loading coroutine says, okay, I know I must have a player because the script won't start without a player, but I need to wait until my player's loaded, till my player has a skeleton. And so I'm just going to wait for 1 second and 1 second and 1 second until, oh, okay, I have a skeleton now. And then once the skeleton exists, it goes, okay, try and find those skeletons' toes. If you can't find toes, try to find those skeletons' feet. If you can't find toes or feet, then there's no real point in running the rest of the script. So if there's no foot of any kind that we can find on this character, then we're done. We're simply not going to do anything. But if both of these, if we've managed to find both a left foot and a right foot of some kind, then we're going to go ahead and start up our dancing coroutine. And that otherwise works exactly the same as before. The thing that we might need to change is this this distance from the ground that we're scanning. And so we'll try it and see what happens. If we're not getting anything, we may need to come in and adjust this distance. And that's something that we could be a little bit smart about in the future if we wanted to. Like on startup, once we found a foot, for example, we're like, okay, we found a foot. We'll assume that on loading that both feet are on the ground. And so right off the bat, we're gonna be like, okay, we loaded, we have a skeleton now. We're probably just standing there when we just loaded. And so I can run a raycast here right away and figure out how far off the ground my foot is, and then use that as my distance for detecting whether my foot has come off the ground or not. So that's possible to kind of make it self-adjusting. But let's just see how our little test works here. If we come over here and we just play this. Come on. Unity's taking its sweet time starting up here. There we go. Okay, let's check our console. Did you find anything? Did you find my feet? I'm not actually getting anything from that I can see from the. It is running though, because it did make the. It did make the effects. So maybe it's stuck in a loop here. Let's see what's going on. Logger.log, player not loaded yet for no skeleton. Let's check our logic here. So if they're not, if they don't think they're loaded or their skeletons equals nil, that should be the case. So let's see. Yeah, I'll put a copy of the script in here when we get done with this. Everybody can have that. Is it working and I'm just missing it? Oh, yep, I did get a little particle effect there. So it is working. I'm just not getting, oh, you know why I'm not getting that? And that's going to be because I did not add, so we don't need that. That's just not working because I didn't add a true to the end of this. All right. So we play this. It's actually working the whole time. My logger wasn't turned on correctly. All right, so we've got our effects, got our dancer over there. And we can see that if I fly up here and then fly back down, that's kind of hard to see, but there we go. All depends. We can see that like this is where I was talking about like the height is not really detecting it properly. Sometimes when I go down, my toes dip and that works, but obviously the height here is a little bit higher off the ground than before. So we kind of need to have a uh, a longer detection range here. So we're going to set this to like 0.2 of a meter instead. That may be too far. Let's actually try it at like 0.15 to start off with and see how that works for us. All right, so we're loaded. So we fly up and we fly back down. There we go. We're getting a nice little impact anytime I hit the ground. Let's make ourselves dance here. If I could just come over here to my player object, what I'm just going to do is just drop my dance controller on myself. There we go. Now I'm dancing. We're both splashing. Got a nice little effect there. All right, let's restart that. And let's see let's just see if our walking animation actually is enough to trigger this. If I'm picking my foot up enough to matter. Oh, it is. I am picking my foot up enough to matter, barely. But every time it's kind of a since my feet are so close together, it's just splash, 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 splash. If I'm running, you see, it kind of makes more sense if I'm running. Every time I put my foot down, I'm getting a little splash effect on that. Walking up backwards. So as you can see, it's not just dancing, it's just literally any time my foot comes off the ground. And if I stop moving, it stops playing effects because I'm not lifting my feet anymore. So yeah, something like this is what you would put in like a dance machine. Like when the dance machine starts up, then you would just do this exact same thing. You would just be like, okay, run the loading routine, make sure that player is loaded and has a skeleton, find their feet, and then start running an animation off of their feet. Now, the thing about this is that this is obviously not networked, right? I'm seeing this on for me. Um, and obviously I would want everyone else to see when my foot impacted. And so the dance machine would have to be smart enough to run a version of this for everyone who was dancing. And dance machines already have to deal with networking, right? If I start myself dancing, then I'm only going to see myself dancing on my screen unless the dance machine is smart enough to network my dancing to everyone else. Um, uh, it could be put through a state machine, kind of. You can't put a state machine directly on the player, but if you had an object that was just like, yeah, if you click this, then it starts up, a networked state machine. You could do that. you would still have to, like you still have to have one per player, and it would have to be like not just networking. You'd have to like make a copy of it, be like, okay, this copy is for this player, but then you'd have to have some way to specify which player that machine belonged to. You could do something like that by, naming the player, like make a copy of this. But then you'd have to also make a copy of it on everyone else's machine. So you'd have to like network the duplication of that state machine before that state machine can then do its own networking. So it's kind of not really a good use case for that. Um, you'd really probably want to just have the script do the networking to start off with. Like I said, any dance machine is going to have networking built into it already, where the dance machine goes, "Hey, I want to dance," and you pick a dance, and then it tells everyone else, "Hey, Josh is dancing and doing this particular dance," and the dance machine handles networking both me seeing it and everyone else seeing it. So this is just something you would insert there and say, in addition to starting up a dance on this person's avatar, also start up this other coroutine that does the particle effect. It wouldn't have to be a separate networking thing. Um, if you didn't have control of the dance machine, like if it wasn't your dance machine and you didn't have access to the scripts to sort of insert this in there, you could do your own networking setup in here. It's just that detecting when the dance was happening would be was started and stopped might be where you where you get lost, but there's ways around that. Like you could have it start up whenever they're on the dance floor, for example. And just if you're on the dance floor, this is active, and whatever dance you're doing just automatically happens. Um, you might also be able to do. I don't think it's possible to detect custom animation that's playing. No, you can start it because most dance machines just use like play custom animation and stop custom animation. But I don't think we have anything in here that lets you get what the current animation is. I mean, there's some ways around that are a little bit convoluted. You could go into like the S animator component, for example. You could get the player's animator, and then you could watch what um, the player's current animation state is, and then detect if their animation state um, switched into the way our animator works is when you play a custom animation, it switches to a particular state on the user's animator, so you could detect whether their animator's state has changed to a state with the name that you care about, and then start the effect up. And then if their state changes away from that, so they're not playing a custom animation anymore, then stop. But that wouldn't help you for like dance balls that swap out the player animator for a completely for a more advanced animator, which some dance balls do. So if you didn't have control of your own dance ball, I would probably recommend just going the route of um, have a big like collider trigger box and put it over the dance floor. And when the user enters that collider trigger that says, "Hey, they're on the dance floor," then start this up for them. And when they leave the dance floor, then turn it off for them. And that way, anytime they're on the dance floor, anything that they're doing, moving, they're getting this effect. And if they leave the dance floor, then this effect just goes away. But if you build it into the dance machine, then you kind of have the bonus of um, it works anywhere. Even if they're not dancing on the dance floor itself, if they're dancing on top of the bar, it would still work, right? Because that's based on when they start and stop dancing versus the location where they are. But yeah, I mean, it's just generally this can be used for any time you want to detect. Like I said, you could expand this so that like, okay, what if you're doing like break dancing and sometimes it's not their feet on the floor, maybe sometimes they're doing a handstand and you want, the same effect to come out of their hands. Then it would just be an extension of this, right? Where in addition to keeping track of their left and right foot, you'd also keep track of their left and right hand, and you'd be doing that same raycasting from their hand and playing an effect out of their hand if their hand got within the floor. You want to be careful just because like raycasts can be expensive. These are very short raycasts. Keeping them as short as possible helps keep cut down on how much they cost to run each frame. But you don't want to be just doing like hundreds of raycasts all the time from 20 different body parts if you can avoid it, because then you're just adding a lot of load to each frame, especially if you've got, might be okay for one or two dancers, if you're putting on some kind of special show or performance. But if you're in a club and there's 40 people dancing, and you're having to do 4, 5, 10 raycasts from each dancer every frame, then that can get to be kind of performance intensive for the user, depending on particular kind of machine that the user has, and that sort of thing. So some just got to keep in mind that sort of performance impact that you're going to have when you scale up to a lot of users. But both these scripts are good. I started with the mannequin just because it was simpler. Obviously, if we look at the dance effect script, this part is the same, but the setup part is easier, right? We didn't have to worry about whether the player's skeleton was loaded or not because the mannequin always has a skeleton. Um, Now that's not necessarily true if you're using like our statue component. Our statue component is just a block, and you feed a outfit ID, and even though it's an NPC, it loads a real outfit like a player would. And so for like our statue component, you would have to do the more complicated. Okay, make sure the statue's loaded, make sure the statue has a skeleton and so forth. But if you're just putting the model directly in the scene, you don't have to worry about that. You can just do the simple effect, tell it where the toes are, and off you go. But if you're attaching it to something that uses our outfit system, then you kind of got to be more mindful of that. But yeah, so both of these versions, they can work on players or they can work on um, characters. If you've got NPCs dancing in your scene, then you can still make them have the effect as well. The nice part about using our statue system is our statue system, it works exactly the same way that our players do. So the code is basically all the same. The only difference is obviously you would be referencing something other than the player if you were loading it on a statue component. But yeah, just something a little fun. I'll drop the script in the general chat. I'll drop both scripts in the general chat if you guys want to play with it. Um, you'll have to find your own particle effect, which let's talk about a little bit briefly, just because I mentioned earlier that the particle effect, if you're doing it this way where you're moving the source of the particle effect around, can be weird if the particles aren't set up correctly. So just looking at how these particles are configured, one of the things is obviously I turned off play on awake because we're making this ahead of time, and then we only want it to happen when we trigger it specifically. We don't want it to just play as soon as we create it. So play on awake's turned off. We don't want it to be looping, so looping's turned off, right? Because we want it to happen once when we say impact has happened, play. We want one little poof, and that's it. We don't want it to sit there and play continuously. So you can take a looping particle and just turn off the looping and just get like one little puff from them. And then the other thing, though, to be aware of is the simulation space that particle is happening in. And if you have a particle that's happening in local space, then what's going to happen is that as you move that particle object around, the particles that it emits will move with it as if they're children of that object. If you have multiple objects and one object is parented to another object and you move the parent around, it moves the child around with it. And so that can look pretty weird with particles because you're like, instead of the poof happening and just dissipating where it happened, and if you had like rapid impacts in a row, you'd see those particles actually physically relocating themselves instead of just the source relocating them. So having those simulated in world space is an important part of that looking right. And then something else is you probably don't want the particle effect to last very long. Like you want just like an instantaneous poof and that's it. If you had some kind of like really long, elaborate particle effect, then you would again see that situation of I'm moving the particle emitter around. So if it's a long particle effect, if something's happening over like 2 seconds or something, then I get rapid impacts on my foot while I'm dancing, then you're going to see that particle emitter move around. The particles themselves wouldn't move around if the simulation space is in world, but the emitter would move around, and if it's still emitting when it's moving, then it's going to look a little bit strange. So kind of the ideal particle something here is fast, instant, in world space, not looping, and then you get that nice little poof, poof, poof as your foot hits the ground. And the particle effect can be anything you want it to be. And you kind of want to play with what that looks like and the particle lifetime and stuff to kind of get the best result out of it. But any particle system should, in theory, work. And you could also do things like add an audio source and trigger off a little fast audio burst if you wanted to. That might be annoying if you're dancing in a club and there's music. You may not necessarily want to have audio interfering with the music, but maybe you do. Maybe that's part of the effect that you're going for. And like I said, you can also like randomize the sound or randomize the particle effect that's happening. You can get creative with it. You don't have to use the same effect over and over again or the same effect for every person. You can mix it up and just and get that way. Not everybody's red. Like I said earlier, you could have people with different colors, and so it's easier to distinguish even if two people are dancing next to each other, whose footsteps or setting off those particles, because one person's green and one person's blue, and so you can see individually. If they're both the same color, then it might be unclear as to who actually emitted those particles if they're standing next to each other. So yeah, we'll call that good for today, unless if anybody has any questions. But just I thought I would just do something a little bit fun, something visual that actually you can see. A lot of scripting tends to be spending a lot of time in a script editor, and the effects of it tend to be, sometimes a little bit dull to actually look at versus because it's mostly coding. So I wanted to do something that was a little bit more visual and hopefully something fun that you guys can take and play with in the actual world and come up with some fun ideas with this. Can we do something fun with a rigid body on an avatar next time? Um, Maybe. That's a little bit difficult because we can do it on a humanoid like NPC easy, but doing it on the player um, takes a little bit of messing around because you have to either disable or fight with the character controller that is constantly trying to be in charge of where the avatar is and what it's doing. So if you want to like ragdoll the character, then you have to get a little bit more creative with it. But yeah, we might be something we can look at next week and see if we can do something with that. I kind of feel like maybe we did on a previous call when these were still internal. I think we did an internal call where we were playing with physics and we made a cannon and we talked about what it would take to shoot a character out of a cannon. So like a big circus cannon or something. So that might be interesting. I don't think we actually did it. I think we just talked about it. I don't remember. I'd have to go back and look. But anyway, yeah, we'll see what we can do next week. But I'm going to go ahead and stop the recording there.